Hello, Rhoffun.
Hello.
Okay, so let's start with the technical round. So the first question would be, can you describe a scenario where you applied sentiment analysis to improve customer experience?
So I developed sentiment analysis model to analyze customer feedback and product review. By applying this sentiment analysis model, I was able to identify customer pain points and satisfaction drivers. The insights were used to refine products, offering, and enhances the overall customer experience. For example, through sentiment classification and topic modeling, we identified common issue with product availability and use this data to inform supply chain decision, ultimately reducing negative feedback.
That's wonderful. Okay, Rhoffun, what techniques did you use to implement a demand transfer model at the store cluster and SKU level?
So I developed the demand transfer model using XGBoost. I tried a lot of different models, but XGBoost seems to be working best for us, which help predicting demand shift across different stores, cluster, and SKU. The, the model leverage historical sales data, store locations, and promotions to accurately forecast how demand would be distributed, where certain products were unavailable or promoted differently. Additionally, Additionally, I used feature engineering to create variables that capture seasonality and consumer behavior, improving the model's predictivity accuracy.
What challenges did you face when creating a resume parser using YoloX and Bi-directional LSTM?
One of the main challenges was ensuring accurate extraction of relevant information from various resume formats. YoloX was used for object detection, identifying key sections such as education, skills, and experience, while bidirectional LSTM handled named entity recognition to classify the extracted information. The, the challenges lay in dealing with inconsistent formatting across resume, which required additional rule-based approaches to ensure data integrity and improve the parser's performance across diverse groups.
How did you approach building a price elasticity model that achieved 93% accuracy?
For price elasticity model, I used combination of log-log regression, GAM, which is generalized entity models, and the double MS frame to capture the relationship between price changes and demand at both the product group and SKU level, basically product PPG group. I focused on feature engineering by incorporating factors like competitive price, seasonality, and promotional effect. To ensure high accuracy, I tested the model on out-of-time data and optimized it with cross-validation and hyperparameter techniques, achieving 93% accuracy.
How did you utilize constraint programming in your trade promotion optimization TPO model?
So the TPO model constraint programming was applied to optimize promotional decisions under various business constraints such as budget limits, inventory availability, and promotional timing. After building an initial predictive model with XGBoost and GAN, I used constraint programming to ensure that the recommended promotions were feasible and aligned with business rules. The approach helped in maximizing sales impact while staying within operational limit and offering a practical solution for decision makers.
Can you explain how SHAP values were used to interpret the result of your XGBoost based models?
So sharp values were used to provide interpretability for the XGBoost based model by quantifying the impact of each feature on the model's output. This allowed for a clear understanding of how specific factors such as pricing, reviews, or availability influence sales predictions. Sharp values break down each prediction into feature contribution, making it easier for stakeholders to trust and act upon the model's insights, especially in business critical applications like sales attributes or demand forecasting.
What strategies did you implement to reduce transportation charges using Google OR tools?
Using Google OR tool, I developed a load consolidation algorithm aimed at optimizing transportation logistics. The strategies focused on minimizing the number of trips by effectively combining shipments. By considering factors such as vehicle capacity, route distance, and delivery schedule, the algorithm found the optimal way to group orders and reduce empty space in shipments. This approach led to a 30% reduction in transportation charges while maintaining delivery efficiency.
I see that you have experience with Selenium as well. So, how did you implemented web scraping using Scrappy and Selenium for automated data extraction?
I use Scrappy for efficient, scalable, and web scraping, focusing on extracting structured data like tables or lists. For more dynamic websites that required interaction, I integrated Selenium to simulate user behavior. This combination allowed me to automate the data extraction process from both static and dynamic website, gathering large amount of data for further analysis, such as building dataset for machine learning models or business analytics.
How did you handle data cleaning and feature engineering in the development of your machine learning models?
Data cleaning involved removing duplicates, handling machine values through imputation methods, and ensuring consistency in categorical data. For feature engineering, I focused on creating new variables that captured domain-specific insights such as interaction terms or lag feature for time series data. I also transformed feature using technique like normalization or one-hot encoding to prepare the data for machine learning models. These steps improve the quality of inputs, leading to better model performance and predictivity accuracy.